Velocity time graph. Now, in velocity time graph, say we have a graph like this. We plot velocity along y-axis. Unit of velocity is meter per second. Time in seconds. Suppose you have a graph like this. Now, this type of graph, what does it tell us? That velocity is zero. Velocity zero means body is not moving at all. Body is at rest. So if you have a graph like this, it implies that the body is at rest. Looking at the graph, we should be able to tell about the motion of the body. Now let us look into case 2. This is velocity in meter per second. This is time in seconds. See, we have a graph like this, parallel to the x-axis. Now what does it indicate? Say, at time t equal to 1 second, say velocity is 4 meter per second. At time 2 seconds, velocity is again 4. 3 seconds, velocity is 4. 4 seconds, again velocity is 4. That means from here we can say that body is moving with uniform velocity. Body is moving with uniform velocity, constant velocity. And if body is moving with uniform velocity, acceleration is change in velocity by time. There is no change in velocity. So this is 0 by t. So my acceleration is 0. Now like the slope of displacement time graph gives us the velocity. Here, slope of velocity time graph gives us acceleration. like slope of displacement time graph gives us velocity. Now what was slope? If you remember, this was a graph. This angle theta, slope was tan theta, which was perpendicular by base. This is 90 degree. This was perpendicular. This was base. Slope is the tan theta, which is perpendicular by base. Now in this graph you see the angle theta is 0. So slope is 0. If slope is 0, what does the slope gives us? Acceleration. So if slope is 0, acceleration is 0. So slope of velocity time graph gives us acceleration. Now here, one more important point to note over is, children, the area under the graph, say if I draw the area under the graph, gives the distance or the displacement covered. Area under the graph gives a measure of gives us a measure of distance or displacement covered. Distance or displacement covered gives us a measure of distance or displacement covered. Gives us a measure of distance or displacement covered. So by finding out the area, we can find out. By finding out the area, we can find out the distance or the displacement. Now, when we will get distance and when we will be getting displacement, we will study later on. But two important points. One, the slope gives the acceleration. Number two, the area under the graph will give us the distance or the displacement. Case 3. See, if you have a graph like this, this is velocity and this is time. Say you have a graph like this. That means velocity is increasing with time. Say for 1 second, velocity is 2. For 2 seconds, my velocity is 4. 3 seconds, velocity is 6. 4 seconds, say velocity is 8. 5 second, velocity is 10. And say 6 seconds, velocity is 12. So this type of graph, what does it tell us? This type of graph, what does it tell us? That velocity is increasing with time. And when velocity is increasing with time, what do we have? It is an accelerated motion. And how do we get the acceleration? From the slope of the graph. Now, what is slope? Slope is tan theta. This angle is theta. Slope is perpendicular by base. So perpendicular is 12. Base is 6. So acceleration is 12 by 6. This is change in velocity, which is meter per second. Time is in second. So it is 2 meter per second square. It is 2 meter per second square. So by finding out the slope, we can get the acceleration. Now we can take even the smaller triangle. The answer will be the same. Say for example, if I take a small triangle and find the slope, this is 8 minus 6. This is 2. And this is 4 minus 3. 1. So perpendicular is 2 and base is 1. So if you take for this small triangle, the slope is 2 by 1. So acceleration will remain the same. For a straight line graph, the slope does not change. Now, if someone tells you what is the distance or the displacement covered over here, area under the graph, this area gives the distance or displacement. So it is the area of the triangle, say OAB. Area under the graph is the area of the triangle OAB. So the distance covered is the area of the triangle OAB. Formula for area is half into base into height. Here it is a triangle. Always it won't be triangle. It can be any figure. Now this base is 6 and height is 12. The height is 12. This is the height. So this will be half. Base is 6. Height is 12. 2, 6 are 12. Distance covered by the body is 36 meters. That means if a body starts from here at the point O, it accelerates. It starts with the initial velocity 0, accelerates with 2 meter per second square, and then with this acceleration it covers a distance of 36 meters. With this acceleration it covers a distance of 36 meters and reaches the point A. Now if we have a graph like this. This is velocity. This is time in seconds. If you have a graph like this, that means with time the velocity is decreasing. So here we can say there is retardation. Velocity is decreasing. Retardation means negative acceleration. Say for example, children, say this point is say 4 and this point is 2. The slope is this angle. So acceleration is negative. This is 90 degree. So this is the perpendicular. This is the base. Acceleration is negative slope. What is slope? Slope is perpendicular by base. So it is minus 4 by 2. So it is minus 2 meter per second square. Acceleration is minus 2 meter per second square. Now, if anyone asks you, what is retardation? Then do not give the negative sign. Retardation means negative. It is 2 meter per second square. If it is retardation, do not give the negative sign. Now comes the distance or the displacement. As I told you, distance or displacement is the area under the graph. So the distance traveled by the body is half into base into height. Now what is the base? It is 2. And what is height? It is 4. This is the height. It is 4. So distance covered by the body is half into base into height. So what is the distance covered by the body? 4 meters. Now what does this mean? That means the body is starting. My initial velocity was 4. Usually U is denoted as initial velocity. My initial velocity is 4. Now the body is moving. It has given a brake. Say a car is moving. It has given a brake. So it's moving with reduced velocity. Velocity is decreasing, decreasing, decreasing. But the body is moving forward. Means the body is moving with a less velocity. There is a negative acceleration. And at 2 seconds, the velocity becomes 0. At this point, my velocity becomes 0. From the graph, everything should be clear. Time 2 seconds, velocity becomes 0. And the area gives the distance covered. So this distance covered is 4 meter. The body has covered a distance of 4 meters. Now, if we have a graph like this, that is case 5. Say, this is velocity in meter per second. This is time in seconds. Say you have a graph like this. Velocity is -2 meter per second. Say this time is 4 seconds. Now what does negative velocity mean? In the previous video I've told you that negative velocity means body is returning back to the starting point. In the displacement time graph we have learned negative velocity means body is returning back to the starting point. Here velocity is negative. So what can we say? Although the velocity is uniform, here the velocity is constant. So we can say it is uniform velocity. Velocity is not changing. Uniform velocity means acceleration is 0. The slope of the graph gives acceleration. In this graph, the slope is 0. So acceleration is 0. The body is moving with uniform velocity, no acceleration, but it is returning back. It is returning back. That means if this is my starting point, A, my velocity is 2 meters per second, and say this is my house. Okay, this is my road. I've gone to a certain place. Velocity is not changing. So what I can say that I am returning back to my house. I'm returning back with a constant velocity. Now, if someone asks you, then what will be the distance time or displacement time graph look like? So from here, if you are asked to draw the displacement time graph, velocity is uniform, it is constant, but I am returning back. So the graph should be like this. Graph should be like this. Uniform velocity. Straight line has uniform slope. Slope of displacement time graph gives velocity. The slope is uniform. What is slope? Perpendicular by base. Now slope of displacement time graph gives velocity. Now what is the slope here? Velocity is 2. So slope should be 2. Perpendicular by base should be 2. In this case, and what is the distance covered if you are asked? Distance covered can be calculated by the area. What is the distance covered? It is a rectangle. Distance we will denote by small letter s. It is the area of this rectangle. OABC. It is the area of this rectangle. This is length into breadth. This is 2 and this is 4. So distance is the area under the graph. It is the area of the rectangle. It is the area of the rectangle. OABC. That is length into breadth. That is 4 into 2. 8 meters. The body has covered 8 meters. The area under the graph gives 8 meters. And since it is negative velocity, it means body is returning back. Body is returning back to the starting point. Now, case 6. If the graph is a curved one, say this is velocity and this is time. If the graph is a curved one, slope of velocity time graph gives acceleration. So if you want to find the slope over here, if this angle is theta 1 at the point A, at the point B you see the slope has increased. And at this point the slope has further increased. Theta 3 is greater than theta 2 is greater than theta 1. So what happens? Slope is increasing. Slope of graph is increasing. What does the slope give us? The slope gives us velocity. So we can say velocity is increasing. Sorry, the slope here gives us acceleration. The slope of displacement time graph is velocity. The slope of the graph is increasing and slope gives us acceleration. So we can say acceleration is increasing. But no one will ask you to find out the acceleration because this can only be done with the help of calculus. And what about the distance covered? The distance covered is the area under the graph. This is also not possible. This can only be found out with the help of integration in calculus. In class 11, we will find out this area with the help of calculus. But for the time being, we have to know what the graph tells us. The graph tells us that the acceleration is increasing. Now say we have a graph like this. Case 7. This is velocity time. We have a graph like this. The slope gives us acceleration. At this point, this is my slope. See, the slope is decreasing. The angle is decreasing. The slope is decreasing. Theta 3 is less than theta 2. Slope is decreasing. What does the slope gives us? Acceleration. So we can say acceleration is decreasing. Now here children make a mistake. What is the mistake you make over here? Very often children say, here velocity is decreasing. Children, it is wrong. You see velocity is increasing. Say at 1 second velocity is 2. 2 second, say velocity is 6. Say 3 seconds, velocity is 7. Velocity is increasing. It is not that acceleration decreasing does not imply velocity is decreasing. It means velocity is increasing. But it is not increasing as it was increasing before. Say for example, you start your card from here. This is your card. This is your card. Here you are accelerating with high speed. Say acceleration is 10 meter per second square. You are moving. After some time, you are accelerating with 5 meter per second square. Does it mean that your velocity will decrease? No, your velocity is going on increasing. But previously it was increasing. Previously it was increasing with a rate of 10 meter per second square. Now it is increasing with 5. Your acceleration has decreased, but velocity increases. Velocity is increasing. Acceleration decreasing does not imply that velocity decreases. It implies velocity increases, but less. It was increasing more in the beginning with a high acceleration. Now acceleration, you have reduced your acceleration. So your car is increasing the velocity, but with a lesser space. Less. It is increasing less. Now suppose if you have a graph like this. Say you have a graph like this. Suppose you have a graph like this. What does it mean? See, the slope gives us acceleration. This angle is theta 1. The angle is increasing. Slope is increasing. And what does the slope gives us? Acceleration or retardation? Now here, with time, the velocity is decreasing. So in time t equal to 1 second, my velocity was 10. 2 second, my velocity is 8. 3 second, say my velocity is 2. So velocity is decreasing with time. Time is increasing, but velocity is decreasing. Here we can say there is retardation. Velocity is decreasing. But the slope is increasing. And what does the slope gives us? Acceleration. At the same time, velocity is decreasing. So we can say retardation is increasing. Why are we telling retardation? Because here velocity is decreasing with time. Here also we won't be asked to calculate the retardation or the distance, because distance without the help of calculus, you cannot find the area of the curve. Now suppose we get a question like this, or one more case let me discuss. Say this is velocity time. Say the graph becomes like this. What is the slope? At this point, this is my slope. At this point, this is my slope. Slope gives acceleration or retardation. Here again time is increasing, but velocity is decreasing. So it is retardation. Slope is decreasing. Angle is decreasing. If slope is decreasing, we can say that retardation is decreasing. Here again, you won't be asked to find the distance, because it can only be done with the help of calculus. 2 points to note over here, children. Points to note. Velocity time graph can never be a straight line parallel to the velocity axis. Say this is velocity. You can never have a graph like this. What does this mean? This means velocity is increasing without an increase in time. How is it possible? How is it possible? The time is not increasing, but velocity is increasing. So this type of graph is wrong. You can never have this type of graph. It means acceleration is infinite. It means acceleration is infinite, which is impossible. This is not possible at all. Another point to note, children. Suppose a body is moving with an initial velocity. So it has a velocity. A body has some initial velocity, say. It has an initial velocity of 2 meters per second. It accelerates and it accelerates and it moves over here. Say this is 8 meters per second. This is, say, 4 seconds. Now in this case, how do you find the acceleration? It is the slope of the graph. You have to complete the triangle like this, 90 degree. Now this is perpendicular. This is base. So here, acceleration is a slope perpendicular by base. Now what is the perpendicular? This is 8 and this is 2. So this perpendicular is 8 minus 2, 6. And this base is 4. This is 4. So it is 6 by 4 meter per second square. It is 1.5 meter per second square. Now how do you calculate the distance covered? The distance covered is this area under the graph. Now you can do it in two ways. Either you can find the area of this rectangle and the triangle and add up. You can find the area of this triangle and the rectangle and add up. Or you can do it with the help of the formula of a trapezium. Now for the time being, for those who don't know the formula of a trapezium, I am finding out the distance covered by the area of the rectangle. Let me name it for your easy, take blue color, O, A, B, C, D. It is the area of rectangle OACD is the area of this rectangle. OACD plus the area of the triangle ABC. So what is the area of the rectangle? It is length into breadth. So this is 2 and this is 4. So area of the rectangle is 2 into 4 plus what is the area of the triangle? Area of this triangle is half into base into height. Now base is, this base is 4 and this height is 6. This is 6. So half, base is 4, height is 6. So simply add up 8, 4 into 2, 8. This cancels, plus 12. So here the distance traveled is 20 meters. This can also be done with the help of the trapezium. Before we end, one more point, children, and I can tell you. Say we have a graph like this. This is velocity in meter per second. This is time in seconds. Say I have a graph like this. Peculiar graph. Say this area is 10. This area says 2. This area is 4. This area says 1. And say this area is 20. Now what does the area gives us? Distance covered. Now let me name this as S1, S2, S3, S4 and S5. Now what does this graph mean? I'm starting from here. Starting point. First S1. I've gone 10 meters. Area is the distance. I've gone 10 meters. S1 is 10 meters. Next S2 is 2. But velocity is negative. This is the negative velocity. Negative velocity means body is coming back. That means I have come back 2 meters. This come back 2 meters. S2 is 2. Next S3 is 4, but velocity is positive. Positive means you're again going away from the starting point. This is my starting point. So now I'm moving away. I'm moving away 4 meters. So from here, I go 4 meters. Because the area is 4 and velocity is positive. This was S3. Now S4 is 1, but negative velocity. It is negative velocity. That means I come back 1. S5 is 20, but velocity is positive. Velocity is positive. So I move from here 20 meters. So what is my distance covered, children? What is my distance covered? How much I have walked? I have gone 10 meters. I have come back 2 meters. I have walked 10 meters. I have come back 2 meters. Then I have gone 4 meters. Then again I have come back 1 meters. Then again I have walked 20 meters. So this is my distance covered. Just add. But what is my displacement? Here distance and displacement is not same. What is my displacement? Displacement is the shortest distance between the starting and the final point. So I've gone 20 meters, I've come back 2, then I've gone 4, then I've come back 1, and then I've gone 20. So what is my displacement? What is my displacement? Here distance and displacement is different. So when you find the displacement, I've gone 10 meters, I've come back 2 meters, so minus. Then again I've gone 4 meters, plus. Again I've come back 1 meter, minus. Come back. Again I've gone 20 meters, plus. So now you see, distance covered is 10 plus 2, 12, plus 4, 16, 17, plus 20. So it is 27, 37. So the distance covered is 37. It is 20 plus 10, 30, 36, 37. But here, what is my displacement? It is 10 minus 2, 8, 12, minus 1 is 11, plus 20 is 31 meters. The answer is not same. 10 meters plus 20 meter, 30, 34. From 34 you minus 3, it is 31 meters. Here the distance and the displacement is not same. So from the beginning, if we come back to the very beginning of this type of graph means body is at rest. Body is not moving at all. This type of graph means uniform velocity, acceleration 0. This type of graph means acceleration is constant. This type of graph means velocity is decreasing, there is retardation, but it is uniform. This type of graph means negative velocity means body is returning back to the starting point. This type of graph, the slope is increasing, slope gives acceleration, acceleration is increasing. This type of graph, slope is decreasing, so acceleration is decreasing, but velocity is increasing. This type of graph means slope is increasing, but velocity is decreasing, so there is retardation which is increasing. This type of graph, the slope is decreasing, but velocity is also decreasing, so retardation is decreasing. Velocity time graph can never be a graph parallel to the y-axis. And if the body starts with an initial velocity, then it can be done in this way. If you have a graph like this, where some part the velocity is positive and some part the velocity is negative, for positive velocity means body is going away from the starting point, and negative velocity means body is returning back to the starting point. In this case, distance and displacement won't be same.